straightforward, but it's super important. Here's why. There is always people that don't pay quite close attention to the meaning of this lesson and what's going on, and then they bomb it on the test because they treat it like a unit circle. And we're not going to look at the unit circle today. What we're doing is we're going to take a second look at trig functions just in right triangles in general. So we have to use these 6 trig ratios. Sine of theta is O heck. Cosine, another hour. Tangent of agony. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So then cosecant will be hypotenuse over opposite. Secant will be hypotenuse over adjacent. And cotangent will be adjacent over opposite. These are the 6 trig ratios we use in right triangle trig. Now yes, the unit circle is right triangle trig, but why in the unit circle? Remember, this is what happens is on the unit circle, isn't it true that sine of theta is always the y value? Cosine of theta is always the x value, and tangent is always the y over x. This only works on the unit circle. Now why is that? So just to recall, isn't the hypotenuse always 1 on the unit circle, radius 1? So that's why we can assume this, but you cannot assume this on just everything. Only if it's on the unit circle. Okay. So we know these 6 trig ratios, now let's just go ahead and use them. Now once again, notice S and C go together, C and S and C go together, so that kind of helps you remember which ones are reciprocals of each other. Okay, so it's really straightforward stuff. You won't even need to take notes for this. It says, what are the 6 trig functions of this right triangle? So we would say, sine, cosine, tangent, cosecant, secant, cotangent. Now first of all, don't we need all the sides of a right triangle to answer all of these? Yeah, so we'll quickly do the Pythagorean theorem to find the hypotenuse. Make sure you set it up correct. 3 squared plus 4 squared equals hypotenuse squared. So that's 25 equals hypotenuse squared. Therefore my hypotenuse is 5. And now I can just answer my trig functions. Sine is opposite, go to theta, opposite over hypotenuse, right? 4/5, so then I'm going to jump right down to cosecant and call that 5/4. All right, cosine is, oh heck, another hour, adjacent over hypotenuse, so that'd be 3/5, jump down to secant, 5/3. And then tangent is opposite over adjacent, my opposite's 4, adjacent's 3, so then we'll jump down and that's 3/4. Straightforward as heck, right? Right triangle trig. All right, so it says, let's just read it. It's just saying the same thing in a little bit more complicated way. It says, let theta be some acute angle such that the sine of angle theta is equal to 0.6. Now everybody, it is always easier to do trig if we have fractions, so instead of decimals. So what is 0.6 equivalent to? Okay, let's put it as not simplified for a second so people can see where it comes from. Isn't 0.6 60%, which is 6 over 10? So isn't sine of 0.6 equivalent to, they both divide by 2? 3/5. Does everybody see how this is the same thing we're given? Okay, it says let theta be an acute angle, so you're going to draw a right triangle, everybody. Now listen to what I'm saying. Do not put in these sides till you put theta somewhere, because it does matter where you put theta on which is your opposite side. So I'm going to put theta down here. Now isn't sine of theta, it says the sine of theta is the opposite over the hypotenuse. So what two sides does it give us? Opposite hypotenuse. So I go to theta. My opposite side we were saying is 3. My hypotenuse is 5. So now I can do the Pythagorean theorem. Make sure you set it up correct. 4. It's 4, yeah. So everybody look how you set it up though. X squared plus 3 squared equals 5 squared. So then x squared equals 16. So x equals 4. So this side's 4. And now you could do sine, cosine, tangent. I don't probably need to do that part. Sine, cosine, tangent. We're good with that? Agreed? Okay. Okay. Let's read this one. It says, let theta be an acute angle such that our tangent of theta is equal to 3. It's always curious to me when people freak out. They say, but 3, well, what do I do now? Because that only gives me one side. No, isn't 3 over 1? Yes, so then you'd say, so tangent of theta is opposite over adjacent. Agreed? Yes. So now you would draw in a right triangle. Put a theta first. My opposite is 3. My adjacent's 1. So let's do Pythagorean theorem. 3 squared plus 1 squared equals hypotenuse squared. 10 equals hypotenuse squared. Then my hypotenuse must be root 10. Everybody listen, decimals are not acceptable. You have to have simplified radicals. Root 10 does not simplify, so I'm good. Write it as root 10. Now all it wants to know is sine and cosine. So we'd say sine of theta is opposite over hypotenuse, so that'd be 3 over root 10. And then that answer needs to be?
Rationalize.
Good, so we'd rationalize our denominator by multiplying by root 10. So don't we get 3 root 10 over 10?
Yes.
Okay, we've answered what sine is. Now cosine is adjacent over hypotenuse, so 1 over root 10, which would rationalize to be root 10 over 10. Pretty straightforward stuff as long as you know right triangle trig. Okay, now let's read this one. It's just giving us more information here. So it says, given that cosine of theta is equal to -5/7, whose terminal side is in quadrant 2, find sine and tangent. Now based on the word terminal side in quadrant 2, I know I need to draw an XY chart here. Quadrant 1, 2, 3, 4. Everybody see? It's just giving us a little more detail than just drawing a triangle floating in thin air. So I'm drawing it right. I'm drawing an XY chart. Here's quadrant 1, 2, 3, quadrant 4. Okay, it tells us the terminal side is in quadrant 2. Now how do terminal sides work? Doesn't that mean that it stops in quadrant 2? Does everybody see? I just created an angle. It stops in quadrant 2. Now from here, guys, we've got to create a right triangle. This is cosine of 5/7. So to create a right triangle, we're going to drop down and create a right triangle. Does everybody see? Now here's what you need to understand. You always need to put your theta closest to the origin. Don't put theta up here, but closest to the origin. So I'm going to put theta right there. Now cosine is what two sides? Adjacent and hypotenuse. So I got a theta, my adjacent side is 5, my hypotenuse is 7. Now should 5 be negative or 7 be negative? 5. Because look, this is -5 in distance. Do you agree? All right, now think about it. Would it ever be possible for the hypotenuse to be negative?
No.
You're right. No. Why not? Yep. No matter what, negative, positive, whatever, it won't matter because we'll square them, won't we, to get to the hypotenuse? Very good thinking. Okay, so now we'll find the sine, but first of all, we have to hurry and find this side. So wouldn't it be true that we do x squared plus -5 squared equals 7 squared? X squared plus 25 equals 49. So then we'd subtract 25. X squared equals 24. So then we'd square root both sides. Now everyone, decimals are not acceptable, so we do it by hand. 6 times 4, 2 times 2. So isn't it 2 root 6?
Yeah.
2 root 6 is this side, and now we can answer what it's asking. So sine is opposite over hypotenuse, so that'd be 2 root 6 over 7. Tangent is opposite over adjacent. Opposite is 2 root 6. And then because it's in this quadrant, sorry, this is another thing I have to consider. Because it's in this quadrant, wouldn't this be positive?
Yeah.
Because if it was in a different quadrant, that might be negative. And we would have to just know that based on the quadrant, right? Okay, but it's good. Then tangent is opposite over adjacent, so over -5. Okay, awesome. You guys are doing good. Let's keep going with this. Okay, I don't know why I have this XY chart drawn, because it doesn't give us enough information to just draw it in an XY chart. Okay, so it says, given that cosecant of theta is 17/4, find cosine of theta and tangent of theta. I would say, well, I'm dealing with a right triangle here, so I would draw a right triangle. I always put theta first. Now, isn't cosecant what over what? Okay, good. So I'm going to go to theta. My opposite side must be 4. My hypotenuse 17. And then from there, Pythagorean theorem to find this side, right?
1. Oh, no.
No.
4 squared plus x squared equals 17 squared. Agreed?
Yeah.
So x squared equals what? 17 squared minus 16. 270? Oh, 370? Oh, 273. I can't hear. 273 square root x is equal to the square root of 273. Does it break down? Any factors? I would make sure I did divide by 2, 3, 4, 5. I would go for quite a while. Okay, what? It's 3 times what? And then that is, does that divide down?
No. 7 and 13.
Okay, perfect. So now we see that that must be all we can do, right? That doesn't simplify. So we'd write it in, the square root of 273. And now we just answer cosine is adjacent, sorry, cosine is opposite. Oh, no, sorry, I'm thinking about other things. Focus. Adjacent over hypotenuse. So that'd be the square root of 273 over 17, right? Tangent is opposite over adjacent, so that's 4 over the square root of 273, which rationalizes to be 4 root 273 over 273. Then you would just check, does 4 and 273 divide? No, so we're done. Pretty straightforward stuff, right? There's nothing scary here at all whatsoever. All right, now this, I'm telling you, everybody focus, because this is where on the test I have 2 problems, and it says find the 6 trig functions. How many problems is that? That's 12. If you do not understand this, you will not get a good score on the test. Everybody look, it says, given the point on a circle is at -6, -3, find the 6 trig functions. There is always at least 3 to 4 people per class, that's bad, that do this. They say, oh, cosine's x, sine is y. Is this true? No, we're not on the unit circle. Does everybody see? You cannot do that unless you're on the unit circle. Now, how do I know I'm not on the unit circle? Because if I was to do, this is an xy point, however, xy, do I have a radius of 1? No. If we did the Pythagorean theorem, we would not get a radius of 1. Does everybody kind of see what I'm saying? So instead, you're going to have to go ahead and say, I'm going to draw in this point and make a right triangle. So I'm going -6 units, -3 units. So I'm right down here. Does everybody see? Now I'm going to drop down and create a right triangle. And we always drop to here. Where should I put my theta? Good. Closest to the origin. Good. And then wasn't this -6 units? And then -3 units. And now I got to hurry and do Pythagorean theorem. -6 squared plus -3 squared equals hypotenuse squared. So don't we get root 45 equals h? So then we would break it down, wouldn't we? 9 times 5, 3 times 3, so 3 root 5s. And hypotenuse is always positive. So now I can do the 6 trig functions. So we'll just do quick. Okay, let's go like a maniac. Sine is opposite over hypotenuse, so that'd be -3 over 3 root 5. Agreed? Which would simplify to be -1 over root 5, which would rationalize to be -root 5 over 5. Now I'm going to drop straight down and go to cosecant, because it's the reciprocal. Now we could do the reciprocal here, but then don't we have to rationalize? So I'm going to go back one. If I do the reciprocal here, won't I be good? So I have -root 5 over 1, and we're good. Then cosine is, oh heck, another hour adjacent over hypotenuse. That's -6 over 3 root 5s, which is -2 over root 5, which is, so then I can go down to secant and I could flip them and then rationalize, or I could just go back right here and then flip it and I won't have to rationalize. So that'd be -root 5 over 2. And then tangent is opposite over adjacent, -3 over -6, which is 1/2. So then cotangent must be 2. Any questions on that? Don't be that person. Do not be that person on the test that says cosine's x, sine is y, and then you have to do this as your retest when this is very easy. But you get what I'm saying. You do that and it's bad. Do not do that. Okay, hopefully I've made a big enough deal that no one will actually do that. All right. Doing good. Let's go. Okay, everybody write this one down. So far all we've done is we've always been given 2 sides of a triangle, and we were finding the 3rd side using Pythagorean theorem, and then we were just finding the 6 trig functions, sine, cosine, tangent, and so on. Now in this one, we're actually solving for missing side lengths, but we cannot use Pythagorean theorem, because we actually have 2 missing side lengths here. Now notice in this one, we're going to be given an angle and two sides. To solve for y, we're going to have to set up a true statement, which can't be the Pythagorean theorem. Now, it is right triangle trig, so we know it's going to be one of the three main ones. We can use the others, but I usually just use the three main ones. Sine theta, cosine theta, tangent theta. However you remember this saying. I do, oh heck, another hour of agony, but I'd say of algebra because I don't think it's agony to be here. Okay, so everybody look at this right triangle here. Now what we're going to do is we're going to pick an angle theta. Now we never can pick the 90 degrees, so let's just pick 60 degrees because that's very straightforward, it's given. I'm picking that to be theta. Now yes, obviously I could find this angle, but not necessary. Now one more thing to note is don't be that person on the test that goes, this squared plus this squared equals this squared. Angles don't do that. Yeah, question mark. Okay, so instead what we're going to do is we're going to set up a true statement. Now from angle theta, aren't we given the opposite and the hypotenuse side? So which trig ratio uses opposite and hypotenuse? Sine. So everybody look, I'm using sine of theta equals opposite over hypotenuse, and then I'm just inserting everything I know. So sine of theta is, so sine of 60 degrees equals, my opposite side is y, isn't it? And my hypotenuse is 18. Now from here, each time you set up a true statement, your algebra is going to work out differently. So you don't memorize steps. You say, I just need to use algebra to get y all by itself. What would I do? Times 18 to both sides. So isn't my answer? My answer is y is equal to 18 sine of 60 degrees. Now if you're reaching for your calculator, you've got to stop. Here's why. Yes, if you use your calculator, you will get the correct answer. You'll get a decimal answer that you have to round, you know? I want an exact answer. Now isn't it easy to find an exact answer when you're given an angle on the unit circle? In fact, only if you're given an angle on the unit circle can you get an exact answer. Does everybody see what I'm saying? So instead of calculating sine of 60 in my calculator, but like I could, I'm going to use the unit circle to calculate the sine at 60 degrees. So everybody, go to your unit circle. What is the sine at 60 degrees? Root 3 over 2. Does everybody see how instead of my calculator, I'm getting an exact answer? So I have 18 times root 3 over 2. That is the true statement. So then don't we get? Good. These divide out. That becomes a 9. 9 root 3. That's an exact answer. If you would have typed this into your calculator, you would have got the decimal answer. Now on the test, let's say that this would have been 61 degrees. Can we find the sine of 61 degrees an exact answer? No, that would be the appropriate time to use your calculator. Does that make sense, everybody? Okay, now here's how you could check. You could say, did I do that right? You can type in, everybody make sure your calculator's in degree mode. Type in 18 sine of 60, hit enter. You get a decimal answer, which is 15.6, let's just say. Now type in 9 root 3. This is the exact answer of that. That's just the decimal. 9 root 3 is the same thing. It's just one's an exact answer that we can get. That's why we have the unit circle. And the other one's a decimal answer, because our calculator can only do decimals. Everybody good? Okay. This is another one, sorry. This is number 62 on the homework. Yes, it's an even, because I'm trying not to take away the ones that you need to practice. There are two different ways to do this one. Somebody pointed out last hour, if this is 45, then this is 45, agreed? And then this side must be 20, and then set up, and then just go for it. 20 squared plus 20 squared equals r squared. Does everybody see? That is the easier way of doing it. I'm doing it this other way to just show you the algebra behind when this happens. So another way to do it is to set up a trig ratio. So here's our theta. We're given opposite and hypotenuse. I wish it wasn't using sine again. Isn't opposite and hypotenuse sine? So you'd say, okay, I'm doing sine of theta equals opposite over hypotenuse and inserting everything I know. Sine of theta, theta is 45. My opposite side is 20. My hypotenuse is r. Now, I don't know why people get freaked out when they see this, because it's just algebra to get r alone. People go, I don't know how to get r alone. So I'm just going to go ahead and divide by 20. But that would not make sense algebraically. We're way more advanced than that algebraically. Get r alone, what's the first step to get r alone? Times by r over to the other side. So now I have r sine of 45 equals 20. Now get r alone. divide sine of 45, divide sine of 45. Now, I actually like this way, because to me, sine of 45, that's one of the ones I definitely have. The xy points I definitely have memorized. Aren't those root 2 over 2, root 2 over 2?
Yeah.
So then we'd say r is equal to 20 divided by, that's root 2 over 2. But then that answer's not simplified. Now, I recommend from here on out, people, writing in your ones, meaning that's 20 over 1 divided by root 2 over 2. So now dividing fractions is easy as pie. Yep, so 2 would go on top, root 2 would go on bottom. So wouldn't that be 40 over root 2? Good, so you're saying we need to rationalize root 2, root 2. So then we have 40 root 2's over 2, which is 20 root 2's. So yeah, it might have been easier to do 20 squared plus 20 squared equals r squared. But I was just wanting to show you the algebra behind the other one. Okay, awesome. You guys are doing really good. Okay, these are two new words you need to know. Angle of elevation and angle of depression. So angle of elevation is created when somebody's eyes start from the ground and look up to something. It's that angle right there, from the ground up to where they're looking. That is the angle of elevation. Now, angle of depression, people always get wrong. This is the one on the test people miss most because they don't put the theta in the correct spot. People will call the angle of depression Alright, so angle of depression, guys, people will call this right here the angle of depression. It's not. That is not. Angle of depression, notice I have my bat and then it looks down at a person ready to attack. So the eyesight, the line of degrees that was created was eyesight started up here and then it looked down at something, creating an angle theta up here. Now that angle theta is not inside the right triangle. Do you agree? Yep, so you can make your own right triangle over here, or we can find this angle, can't we? This should be 90 degrees, so you could find that angle and then do trig off of that, but even easier is this. Everybody look. If I have this line and they are parallel, and I have a transversal cutting through it, that means a line cutting through, then these are called alternate interior angles. Does anyone know what's true about alternate interior angles? They're the same. So this angle theta up here, the angle of depression, is equal to the angle of elevation. That is a true statement. Angle of elevation and depression are the same thing.
So does it always go to the lowest point?
What do you mean?
Like, it starts down at his foot and then
Yep.
goes up, so it always goes
Yep.
and then is the angle
So guys,
of depression, will it end there?
well, it's just creating a right triangle right here. So if it said, what is the angle of depression from the bat to the human, you would just put in the theta right here, because that's angle of elevation and depression are the same. Does that make sense? And then you can use this right triangle to figure out this hypotenuse length. No, sorry, not the hypotenuse, sorry, the angle. Okay, so let's do an example, one more of the trig stuff. Okay, so it says, what is the angle of elevation to the top of the building if a man walks 50 feet away from the building that is 300 feet tall? So I've drawn my own picture here. I know my angle of elevation from the ground looking up. What if they would have said a person standing up here and they see a person standing over here, and the angle, what's the angle of depression from the person up here to the person down here? Wouldn't this theta be in the same spot? Yes. Okay, cool. Just making sure. Okay, so let's set up a true statement, everyone. You'd say, okay, this is a right triangle. We're going to assume this building was built correctly by the engineers. And we have a opposite and an adjacent side. You have to use the correct trig ratio based on what you're given. So I always have people just use sine because they're like, I like sine, but you can't use sine unless you're given opposite and hypotenuse. We're given opposite and adjacent, so we have to use. Yep, so we have tangent of theta is equal to, now we don't know theta, in this one that's what we're trying to find, tangent of theta is equal to, my opposite is 300 divided by the adjacent, which is 50. Now, yes, we can simplify it or we don't have to, but we can, so that is tangent of theta equals 6. Now technically, guys, understand something. Tangent of theta, a lot of times we get lazy and go tangent of theta, but that's not tangent times theta. That's tangent of theta. It's like, you know what I mean? It's trappy. trapping it. Tangent of theta trapped inside. Just like a logarithm traps something inside. You know what I'm saying? So if I said to you, we need to use algebra to get theta alone. When we had a logarithm, we based both sides, correct? But when we have a tangent, we've got to do the inverse, just like logs and exponentials are inverses of each other. We need to do the inverse of tangent. So luckily with trig, it's really easy. It's literally tangent inverse. Tangent inverse. Inverses undo originals, correct? So I'm just applying the inverse to both sides. Look, tangent inverse undoes tangent. That's what inverses do. So now theta drops out. Theta is equal to. Now just like a logarithm, when we take a tangent inverse or a trig function of both sides, it like eats it, it entraps it. So that's tangent inverse of 6. It eats the other side. Well, we don't have a way of finding an exact answer, so we would just type it into our calculator. And then keep in mind, because it's a degree measure that we're trying to find, you would want your calculator in degree mode. So what is our angle of elevation / depression? 80.5 degrees. Pretty straightforward stuff. Just the algebra worked out a little teeny bit differently. Okay, awesome. You guys are doing great. Okay, now everybody, we are just doing the most basic of basic trig identities today. This is all going to help us build up to when we have to do extremely, extremely advanced trig identities. It's really not bad if you've had a hard time in the past. I don't think your teacher a lot of time gave you a purpose and you didn't understand what was happening with these, and I'm hopefully going to explain that to you. Okay, so start writing them down. You do have to have these memorized for the test, but really they're pretty straightforward. Besides these three, even I have to review these each year and rememorize them. You have to have them memorized because part of being good at math is being able to memorize. And when you get to calculus, the reason we learn these is to be able to have something in a more simplified form, so that if we start doing advanced math with it, that it's easier to do because you've written it in an equal but more simplified form. So as you're writing them down, I want to explain something. So we have sine of theta is equivalent to 1 over cosecant theta. They are equal. Well, now which one would be considered more simplified than the other? Sine of theta, because there's no fractions. It is always better to not have fractions. Did everybody hear that? Listening to the purposes of is really going to help you understand where to go with these. So the sine of theta would be more simplified than 1 over cosecant theta. Everybody understand what I'm saying? Okay, cosine of theta is 1 over secant theta. It would be more simplified if I gave you 1 over secant theta to write it as cosine of theta, because no fractions is always best. Tangent of theta is equivalent to sine of theta over cosine of theta. Now if you were to see sine over cosine, it is more simplified to write it as tangent, because there's no fraction. Now cosecant theta is equivalent to 1 over sine of theta. So if you saw 1 over sine of theta, it would be more simplified to write it as cosecant theta because there's no fractions. Same with this, secant theta is 1 over cosine, so 1 over cosine would be more simplified written as secant theta due to the fact there's no fractions. Cotangent of theta is cosine over sine, and it would be more simplified to write this as cotangent of theta as our final answer because there's no fractions. All right, now these three right here, these are important to really know. When you get to your test, you should write all this stuff down, write these three down, and then also write down any variations that could come from this. So everybody look here, I'm going to make a point. Sine squared theta plus cosine squared theta is equivalent to 1. Now obviously guys, if I saw sine squared plus cosine squared, do you see how it would be much more simplified to write that as a 1? In calculus, if you were to see this, if you knew that it was equal to 1, instead of doing calculus on this nasty bad boy, you'd be doing the same calculus on this, and the answer would come out the same, but 10 times easier. Okay? All right, so then 2 terms is always not as good as 1 term. Do you guys see how this has 1 term? Okay, now there's variations from this, so I'm going to change colors here, and I like to have them written down. You don't have to memorize them. You only have to know this one memorized, and then just go use some algebra to write some variations. Isn't it also true that I could subtract cosine squared from both sides and get sine squared alone? So we also know that sine squared theta is equivalent to 1 minus cosine squared theta. You see how I just subtracted it over? Now everybody listen, what's more simplified? Sine squared theta or 1 minus cosine squared? Sine squared theta, there's only 1 term. That is better than 2 terms. Okay, now let's do another variation. variation. Let's get cosine squared alone. So if I had cosine squared theta, wouldn't I have 1 minus sine squared theta? So if I ever saw 1 minus sine squared theta, it would be more simplified to write it as cosine squared theta because there's only one term. No fractions, one term is the best of all best. Those are the only variations we can get. Agreed? Okay, let's go to 1 plus tangent squared theta equals secant squared theta. Which one, based on what I've been telling you, would be better to write? Secant squared theta, because there's only one term. Okay, let's do some variations. Isn't it also true that I could subtract tangent squared and get 1 is equal to secant squared theta minus tangent squared theta? It would be much more simplified to write this as 1. And then let's go again. If we were going to get tangent squared by itself, tangent squared theta, wouldn't that be secant squared theta minus 1? Okay. And then 1 plus cotangent squared theta is more simplified as cosecant squared theta, because there's only one term here. And then just the variations. So 1 is equal to cosecant squared theta minus cotangent squared theta. And we also know that cotangent squared theta is equal to cosecant squared theta minus 1. Now today, what we're actually doing is we're going to be given, do you guys have those written down so I can go on? Okay, I need you to understand something. This is really important. We are giving you the answer. They're giving you the answer. We're starting out really basic here. This is telling you cosine theta, secant theta will simplify to be 1. It's giving you the answer will be 1. In the future, what our goal is, this is helping us be able to, in the future, not be given this information. And for me to be able to say, simplify cosine theta, secant theta. Do you guys see what I'm saying? In the future, I'm just going to say that. I'm not going to tell you what the answer is. So right now, we're told it should simplify to be 1. And so now we have to just verify and show how we got to 1. Does that make sense, everyone? It's also that in the future, you're not going to be given what it's equal to, but you'd be able to get there. Okay, everybody, here we go. So it says show how this, take the uglier side and get to the prettier side. So obviously this is the uglier side. How did we get to 1? Now what I would do is understand, I usually stick with like sine, cosine, tangent are usually the 3 that I like are the favorites, right? They're the 3 originals. So I kind of stick with those, keep them as is. What I think people do is they get to a trig identity and they look at it and go, okay, so cosine is 1 over secant. And that is, like, they just start changing everything. Don't change everything, go with a purpose. So I kind of leave like cosine is cosine. So cosine of theta is cosine theta. What is secant? So we have cosine of theta times 1 over cosine of theta. So isn't that cosine of theta? So I do equal signs each time. Cosine of theta over cosine of theta, since we multiply fractions straight across, which equals 1. So your work is your answer. Does that make sense, everyone? So some people say, well, Miss Christensen, I can do it in my head. Well, good for you. I don't care. Show the work. Because in the future, you can show me what you can do in your head. Because I'm going to give you a really hard trig function. I'm not going to tell you what it simplifies to be, and you can simplify it and show me that you can get there. Does that make sense? Okay, cool. Doing good. You cannot. Here's one rule, everybody. I have people always think you can move from one side to the other. So they say, I'm going to divide both sides by secant theta. No, no, no. We're literally just using this to prove this side this side is equivalent to 1. You can't move from one side to the other. All right, let's do this one. Let's take the uglier side and make it the prettier side. Which side's prettier? Cosine. Cosine. Okay, so I'm going to draw a line here and say, I just need to make this side that side.
So I would leave sine of theta.
Okay, so you're saying you'd like to leave sine of theta. Now understand there are like 10 million ways to do this. You can do it so many different ways. In fact, there are times when we get to the advanced ones where I'll go do it with one student and it took up a half page. Then I go over with a new student and they thought differently through it and they got it in a half of the time. But they both got the correct answer. It doesn't matter how you get there as long as you get there. Okay, what do you want to write cotangent as? So you're saying that that's cosine of theta over sine of theta? Okay, now you're showing your work. So isn't that sine theta, cosine theta on top? Over sine theta, which is cosine theta, check. We got there. So don't tell me that all trig identities are hard, because this hasn't been bad, right? Especially when you know where you're going with it. Another one. Let's keep going. They're getting more and more advanced. So which side would you call uglier? The left. Okay. Now I agree because there's multiple terms. This only has one term and no fractions. So now if you look at this, 1 plus sine of theta, 1 minus sine of theta, there was no trig identities involving that, correct? So what we're going to want to do is, the only way to change this is to actually distribute it out. Do you agree? Okay, let's do it. 1 times 1 is 1. 1 minus sine theta is minus sine theta. Then we have a plus sine theta, which makes sense because these are conjugates, notice, and middle terms cancel out. And then minus sine squared theta. Now, everybody, I need you to understand, if I write it like this, sine squared theta, it's no different than going sine of theta squared. They're equivalent. Just writing it different. Okay, awesome. So now, don't we have these be added to be 0? So what's my true statement?
1 plus the sine squared theta.
1 minus sine squared theta. Now, is that a straight up trig identity, or is it a variation of 1?
Variation.
It's a variation of 1. So what does that equal?
Cosine squared of theta.
Cosine squared theta. Check. We've reached our goal. Now, in the future, when you're not given that, you would go to here and you'd say, but that's as simplified as we can get, because there's no fractions, one term. Okay. Doing good. Keeping going. We're almost done here. Now, on this one, both sides are almost equivalently ugly. So, it just depends on what you think. Now, here's the thing, actually, I'm going to change my mind and call this prettier because sine squared and cosine squared, this has 2 terms, so does this, but isn't this just a 1? If we were going to do some calculus, it's easy to do calculus on constants, so technically this would be more simplified. So let's see how we can get to that side. Now, don't think you can add stuff, you can't move. Do not move from one side of the equation to the other. That's not how these work. Okay. So if we look at this, we have sine squared theta minus cosine squared theta equals 2, sine squared theta minus 1. Now, because we know where we're going with it, it's going to be a lot easier. Now, do you see how in this answer there's only sines?
Yes.
That gives you a hint that we need to get rid of cosine squared, doesn't it? Okay, so how can we possibly, or what trig identity can we possibly use to write cosine as sine? Okay, so you're saying we have cosine squared theta plus sine squared theta equals 1 was an original identity. And then you said that cosine squared theta then is equivalent to 1 minus sine squared theta. Now look, wouldn't that take cosine squared and rewrite it in terms of only a sine?
Yes.
Yes. So let's insert that in instead because we see in our answer there's only sines. So we're going to go to our cosine squared, which is right here, and we're going to replace it with its equivalent statement. So we still have sine squared theta, don't we? Then we have a minus sign, then a parentheses, because I'm inserting this, 1 minus sine squared theta. Now if you look at your true statement, you'd say I'm on the right track, because now my true statement only has sines. We know where we're going because we're told. This would be a little bit harder to know where to go if we weren't told that. Okay. Now from here, don't I distribute my negative? So I have sine squared theta minus 1 plus sine squared theta. 1 sine squared theta plus another sine squared theta is how many sine squared thetas? So we have 2 sine squared thetas minus 1, and we've reached our goal. Are these feeling pretty good for everyone? Okay. We're almost done with the lesson here. This is, I think, the last one here. Okay, there are so many ways to tackle these problems that there's not a right way and wrong way. There's a right way and long way. So it just depends on how you decide to tackle it. Once you get going, you'll maybe get better. But once again, as long as your algebra works out, as long as your trig identities are not messed up, you'll get the correct answer. Just it might depend on how long it takes you. Obviously, this side's prettier. Let's take this side and go that way. Does anyone have an idea of how they would personally tackle it? There's not right and wrong ways. But you're on the right track of thinking. We can't divide like this because there's a plus sign, but what? You could start changing tangents into sines over cosines. That's one way. I think that's going to be a longer way, which is not wrong. Which is not wrong, because you would get the right answer. Anyone have a different smart idea. Split it up. Yes, so that's how I do it. Now here's why I'm choosing to split it up. Because yes, tangent and tangent would divide out, which would be 1, really nice and pretty. So we gotta just split it up correctly. So we have tangent of theta over tangent of theta plus cotangent theta over tangent of theta. Now once again, if you would have went with the sine cosine option, you would have still got there completely fine. This is a 1, then plus, and then there's many ways to tackle this. What do you want to do? So you said cotangent is? I'm hearing people say? Cosine theta over sine of theta. That's one way. We did it different first hour, but that's fine. Because remember, it doesn't matter. Then what's tangent? Sine theta over cosine theta. Okay, so dividing fractions is easy as pi. Flip the second, multiply. So that'd be cosine of theta on top divided by sine of theta. So now don't we have 1 plus, multiply straight across, cosine squared theta over sine squared theta. What would this be written more simply as? What's cosine over sine? Cotangent? So this is 1 plus cotangent squared, isn't it? So 1 plus cotangent squared theta. And you'd say, well, that's almost completely simplified. If there's not a trig identity, that would be as far as I can go. 2 terms, still not the best. Is there another option?
Yes. It's a variation of one of the...
Okay, so this is equivalent to cosecant squared based on one of our variations, and we've made it. Very good, guys. All right, you guys did awesome with that. Okay, that is the end of the lesson, so homework time, go for it.